If you ever made animations in Blender, you probably had to synchronize sounds to the visuals manually, and it's never fun. So, then you might have tried to spawn or trigger sounds to play from geometry nodes, and then you found out that it doesn't work. It looks like there are no instruments in geometry nodes that would allow us to work with sound in any way. But what if I told you that I made this animation with those sounds being triggered automatically, without me having to edit sounds manually? In this video you will learn how to make this simple animation with tiles randomly lighting up in geometry nodes, and make a system that will trigger a sound to play each time a tile lights up. So first let's make the visual part. It's important to do it exactly like you see in this video, because the sound and geometry node systems are connected in a very specific way. And after we are done with visual part, we will make the system to trigger sounds automatically. Start new file, delete everything but the camera, add any mesh. It doesn't matter what mesh, we are not using the original geometry anyway. Geometry nodes, grid, 1x1 meters, 5x5 vertices, instance on points, cube. Give the cube such size that they fit together with just a little gap between them. 0.245 on X and Y axis and some smaller value on Z axis. Simulation zone, store named attribute. Name it tr_frame for trigger frame. Scene time, connect frame into it. Make sure that store named attribute is in instance domain. Now we're gonna use select input to control for which of the instances we are writing the new value. Random value, integer, between 0 and 24. Scene time, frame goes into seed to get randomly selected value each frame. And just to test it, you don't have to follow along, but to understand it you might want to. Set position, offset on Z, but only if index is equal to the random value that we get. Connect it to selection, and if you play the animation you may see that the random tiles go up each frame, but only for one frame. Let's now make it so that they go up for 10 frames. First add snap here, so that all of this only happens every 5 frames and not every frame. Delete that set position node and connect what we now have into the selection input. Now, if we preview it in instance domain and divide the attribute by 100 to make it more visible, we can see that the attribute we are writing at first has small values and it slowly increases. But we only want the attribute to remember this value for 10 frames, or for however long your sound is. Just for technical simplicity, we are going to move tiles up when they are triggered. That is an easy way to keep track of everything. And at the end we are going to make them stationary, to make the animation just about lighting up and making a sound. Named attribute, set position node. If named attribute is greater than some small value, set position node is active for this instance. But we can't use offset, because it will be applying this offset each frame. We want the X and Y position to stay the same and Z position to be set to a certain value. Add a position node. If we plug it into position, then nothing changes. Separate XYZ, combine XYZ. Connect X and Y, and into Z enter 0.2. Now all of the trigger tiles will go up to 0.2 height and just stay there. We are gonna make them come down after 10 frames. Add another set position node, with the same math, but set Z value to 0, so it puts the tile back down. Selection, trigger frame attribute, scene time. If current frame minus 10 is greater than trigger frame, then the tile has been triggered for 10 frames. And if position Z is greater than some small value, then the tile must go down. Connect it into selection. Now if we preview it, we can see that once the tiles go down, they are still triggered. So we need to reset the attribute value. Add another store named attribute node with the same attribute in instance domain. The logic here is, if the tile is down and is still triggered, we set the value of the attribute of that tile back to 0. Named attribute greater than some small value, and position on Z is equal to 0, then set the attribute value to 0. Now when the tile go down, they are actually resetting. Now move that trigger to the side and select everything but the output and the trigger, and copy it with Ctrl-Shift-Z so that we save the input connections. In that copy we are just going to make 2 small adjustments. There is a way to do it without making a copy that I will show you closer to the end of the video. But trust me, it is easier to understand it if you have that copy with the adjustments. So this copy is exactly the same, giving us the exact same output. But now we are going to make adjustments so that this output will be a technical thing that we are going to use to trigger the actual sounds from geometry nodes. Just to make it more readable, make those instances into smaller cubes. We are not going to see them in the final render. Now for the technical part. Those small cubes will be going up to a different height depending on at which frame they were triggered, and it will tell Blender at which frame to trigger the sound. So here in the simulation zone, set Z position not to 0.2, but to trigger frame divided by 100, connected into Z. If we preview it now, we see that they still move after being triggered. We need to fix it right here. Make sure that the random trigger only applies to the instances that are at Z equal to 0. So it doesn't apply triggers to the same instance multiple times in a row. Previewing it now, we can see that they teleport to what looks like random height. If we turn off the division by 100 here, we can see this instance went up to the height of 10 and it was triggered at frame 10. And this one went up to the height of 15 and it was triggered on the frame 15. So everything works as it should. Bring back the division by 100 so it's more manageable and so that we can actually see what is happening. In short, each instance remember which frame it was triggered at, and it goes up to that height, divided by 100. And after being there for 10 frames, it goes back down. And it is the main logic behind triggering sounds. If an instance went up to this height, then on that frame, multiplied by 100, a sound must play. And those two systems are perfectly synchronized. If we join them, we can see that the instances from the same space are being lifted up. When you join those two outputs into the join geometry nodes, make sure that those small cubes that go to time-specific heights go at the top of join geometry input. It might look like order doesn't matter here because of the way input socket looks. It actually matters a lot for indices of the instances. The upper input will get the lower value indices. How can we make sound play multiple times during the animation and do it through geometry nodes? The base logic is this: add speaker object and select sound for it. Go into nonlinear animation and here you can see your sound. This NLA strip shows when speaker will play the sound. If we can control where this NLA strip is on the timeline, we control when the speaker plays the sound. So if we play the animation, let the sound play, and then move the strip to the frame that didn't yet happen, the sound will play when we catch up to the strip. And again, and again. And it all can be controlled through frame start value. And we control that value with drivers. If we add an empty, scale it down so it's more manageable, go to speakers NLA strip and at frame start, add driver, and in the driver settings set it to scripted expression. In the expression multiply it by 60 just to test it, and select object to be the empty that we added. Here select transform channel, type, select Z location, and make sure that it is in world space. If we let it play and then move the empty up, we can see that we directly control the time at which the sound plays. And that's exactly the logic we are going to use to play sounds in our animation. But again, the final render will not be showing those cubes going to some random heights. It is only a technical thing, and actual visual part is separate and we can make it whatever we want. To kind of start with a clean slate, I'm gonna delete those speaker and empty. Now we are going to have one empty for each of the instances that go to the bigger heights. In geometry nodes, I'll hide the second output so we only work with small cubes we use for logic and not visuals. We want each of the 25 empties to be parented to one of those instances. But of course we can't just use Ctrl-P here, so we are going to use constraints. Scale the empty down so it's just bigger than those cubes. And move it to a separate collection just to keep everything more organized. Name it empty.000. That way the next copies will have consistent naming. To the empty add object constraint, geometry attribute, our main object, domain, instance. In geometry nodes at the end here add store named attribute in the type vector in the domain instance. Connect position node into the value and name it P01. And now in the empty, attribute name P01. Now if you set sample index to 0, this empty will be copying the position of the instance with the index 0 in our main object. Whatever sample index value we input, the empty will copy the position of the instance with that index. Make sure that this one is set to 0 so that name of the empty and the sample index we select are the same. Duplicate the empty and on the duplicate set sample index to the next value. Duplicate that and repeat until we have 25 empties. Starting with empty.000 and ending with the empty.024. Make sure that the name of the empty is the same as the sample index value of that empty. That way you are less likely to get lost later. Now when the animation plays, hopefully all of the empties are following their parent instances. Add your first speaker and just manually put it on the first empty. Scale it down. Select the sound for your speaker. Make sure you have a good amount of different sounds. Adjusting the pitch can only get you so far in Blender. Move it to a different collection and name it speaker.000. And in that frame start value, we add a driver that will be controlled by the empty.000. Add driver. Object, select empty 0. Type, z location. Make sure space is set to world space. And in the scripted expression, multiply the variable by 100, because we divided that value in geometry nodes by 100 a while ago. Duplicate the speaker, move it to the next empty. Make sure you select the NLA strip of the new speaker and only that. Manually click on the track of the speaker that you've just added and then edit its driver. And in the driver settings, just select the next empty, the one that corresponds to this speaker. So when editing driver of speaker.001, make sure that you select the empty.001. Here, when I tested, I can see that this empty goes up and this driver worked and NLA strip moved and sound played. Instance is triggered on the frame 45, the track start is moved to the frame 45 and the sound plays. And after it's done, it moves back to the start of the timeline. So if you have a sound that is longer than 10 frames, adjust this value in geometry nodes to be the same as duration of your sound in frames. Now have some patience and just repeat it for the rest of the speakers, until you have one speaker for each empty. Be careful with your selection and inputs, and you should be done in 5 minutes or less. It may seem like a lot of work, but it's just boring, it doesn't actually take that much time. After we did it, each trigger, the same sound will play, so just select different sounds for your speakers. I only have 12 different sounds, so for the first 12 speakers I select the sounds 0 through 11. Then for the next 12 speakers I do the same, and then I select the speakers 12 through 23, and while holding Alt button I adjust the pitch to be lower, probably around 0.9. For the last speaker I selected a sound and set the pitch to 0.8, so we have a bit of variety in the sounds. Select all the speakers and make sure that volume min is set to 0. That way we retain the spatial audio. You can experiment with the triggering. Maybe removing the snap, do whatever feels right to you here. This is why I directed so much attention to this join geometry node. If we have those two wires flipped, the empties will be copying the position of the wrong set of instances and it won't work. Now we're going to make those tiles stay on the ground. Add set position node, position, multiplied on x and y by 1 and on z by 0. All of the logic that required those tiles to be lifted has already been done and nothing will break if we keep them on the ground. Add two materials, one for the main geometry named cubes and the one for the technical part named transparent. And actually let's make the set position like this, so we can control the height at which they are located. And move it up slightly so that technical cubes don't occupy the same space as the visual slabs. Set material, transparent for the technical part, cubes for the visual part. In transparent material just use transparent BSDF. Here you can see the visual bugs you will get if the geometry intersects, so better offset it. In cube material let's make it light up when it's triggered. Attribute type instancer, type tr_frame to get that attribute from geometry nodes. Preview it and make sure it works. Add value node. There, type #frame to emulate the scene time node, and then copy the math you see in the video. Make sure that the snap checkmark is selected on the divide by 15 node, connected into the strength of emission. Add an HDRI you like, add the base, add the floor, give the base same material as the cubes, make that material less rough and give it subsurface scattering. In geometry nodes you can actually avoid duplications. Make sure you save the backup, then delete the bottom part and do what you see in the video. It allows us to get the same outcome, and while it is possible, I think it was very important to make it with 2 copies, just to understand it better. And now to render it, you go into render settings, and in the output you select video. And in encoding you select MP4, audio you select whatever you like, but probably MP3. And I recommend rendering it like this through View, Render, Play, Blast. That way the animation you render is gonna be from viewport, which is not gonna be used for final visual, but it is gonna render your sound quickly. And after that rendering is done, you set up your usual image rendering and render image sequence, and then you stack them together, but you don't have to manually synchronize the sound. In the next video I will tell you how to apply this to any node group that you might already have. The downside of what we did today is that it is built specifically to trigger sounds as it plays, but I think I figured out how to apply it to any node group.